Need to master GED math, power, and exponent rules? Then you're in the right place. Hi, this is Parker from Test Prep Champions, teaching you how to pass the GED fast, and you can get started by clicking subscribe down below. Okay, so we're going to start off here by looking at one of the most basic cases, but it's very important that we get this down because we're going to move on to some harder stuff here in just a moment. So I want to make sure that we're clear on how to do the basic stuff here. So we see this example here, and it's 3 squared. Now, you could also call this 3 raised to the second power or 3 raised to the power of 2. So there are multiple ways to say the same thing here. But basically, what you have to understand when you get an expression like this, all right, the 3 is the base, and the exponent is our 2. So what does the exponent tell us? The exponent tells us how many times the base is going to appear in multiplication. So to solve a problem like this, we just have to remember that the exponent tells us how many times the base is going to appear in our multiplication. So since the exponent is 2, that tells us that the base will appear in multiplication twice. So to solve this, we just do 3 times 3, and that's equal to 9. Now, a common mistake that students sometimes make is that they think that to solve a question like this, that you have to take the base and multiply it by the exponent. So they think that you would do 3 times 2 to solve a question like this. And I'm going to cross this out here right away because I want us to understand that this is actually the incorrect approach. So if that's how you were thinking about solving this problem, then pat yourself on the back for trying, because now's the best time to make mistakes when you're just practicing, but definitely make a mental note that this is the incorrect approach. So you want to remember that the exponent tells us how many times the base appears in multiplication. So in this case, since it was 2, we did 3 times 3. Now if this hadn't been a 2, let's say that instead this was, let's say, a 9 or a 3 or a 4. Let's say that it was a 4. So let me cross this 2 out here, and let's say that it was a 4. Okay, then how would you solve this question? All right, well, all you would do is you would just remember that the exponent tells us that the base appears in multiplication 4 times, right? So we would do, so if it was 3 raised to the power of 4, we would solve this by multiplying 3 times 3 times 3 times 3. Okay? And so you could easily throw this in your calculator, or you could think about it this way. So 3 times 3 is 9. 9 times 3 gives us 27. Right? So we have 27. And then it's times another 3. So if you want to do this by hand, here's how you would do it. So you could set it up like this: 27 times 3. And we have 3 times 7, which is 21. So we put the 1 down here, and then we're going to carry our 2. So we do 3 times 2, which is 6. Then we add 2, which 6 plus 2 is 8. So the answer to this, if we do it by hand, is 81. Okay, but the most important thing to remember here is that if I gave you this example here, 3 raised to the power of 4, you don't do 3 times 4. You remember that the exponent tells you that the 3 will appear 4 times in multiplication. So you do 3 times 3 times 3 times 3, then either throw it in the calculator or do it by hand like I did here, and in this case we got 81 as our answer. So now we're going to look at some of the most important power rules or exponent rules to know for your test. Now some people call these power rules, some people say exponent rules, but it really doesn't matter what you call them here as long as you understand these. So let's start off with the first one, and I'm drawing the letter A here to let you know that this will work for any number. So no matter what number you have here, okay, you're still going to get the same answer. So any number raised to the 0 power is always going to be equal to 1. All right, so this is just a general rule. Any number raised to the 0 power is going to equal 1. So for example, let's just pick a random number here. So let's say 99. So what if I said, solve this question here. 99 raised to the power of 0, what's the answer? Well, you just have to remember this general rule here, that any number raised to the 0 power is equal to 1. All right, so again, it doesn't matter what it is. It doesn't matter if I have 2 raised to the 0 power. So what is the answer to that? 2 raised to the 0 power? Well, hopefully you remember from a couple seconds ago that any number raised to the 0 power is automatically equal to 1. All right, so this is an important power rule to remember. Okay, so the next power rule that I want to look at here, all right, so again, I'm going to write out the general rule first. So I'm using a here again because it doesn't matter what number you use for the base, you're going to get the same answer. So let's do a raised to the power of 1. So again, any number raised to the power of 1 is just going to give you the base. All right, so in other words, any base raised to the power of 1 is just equal to the base. Okay, so let's just pick some random numbers here. So let's say 11. So 11 raised to the power of 1. What does that equal? Well, remember from the general rule, any number raised to the power of 1 just gives you that base, right? So if our base is 11 and it's raised to the first power or the power of 1, well, the answer is just going to be 11, all right? So one more quick example here. So let's pick something else random. So say I gave you 22 raised to the power of 1, and I said, what's the answer here? What does 22 raised to the first power equal? Well, hopefully you would realize that it's equal to 22. All right, so remember this general rule here. So the first two were very simple, right? So this is another one that's simple, but it's easy to get it confused if you don't practice it often. So just remember that any number raised to the first power just gives you that number. In other words, any base raised to the power of 1 is just equal to that base. Okay, so let's move on now to the next one, and this one is also important. So anytime you have a base raised to a negative exponent, right, so now let's say we have any number raised to a different number, right, raised to a negative exponent here. All right, realize that you can rewrite that as 1 over that same base raised to the same exponent, but the exponent is going to be positive here. All right, so this can be a little bit tricky, but just remember that any number, right, so if we take a base, we raise it to a negative exponent, we can also rewrite it as 1 over that same base raised to the same exponent, but only the exponent's positive. Okay, so let's look at an example here. So let's use 9. So say I gave you this question, 9 raised to negative 2. So if I gave you the question 9 raised to the negative 2, how would you be able to rewrite this? So think about it for a second. All right, now let me show you how you would do it. So that's the same as 1 over 9 raised to the positive 2. Make sense? Excellent. Okay, so let's look at one more example here. So let's say that we have 2 raised to the negative 3. So how would you rewrite this if I gave you 2 raised to the negative 3? Well, if we just remember from this general rule right here, okay, we have a base raised to a negative exponent, so we can rewrite it as 1 divided by that same exact base, which is 2, raised to the same exponent, but only it's positive, okay? Now, how could we solve this out by hand here? Well, we could rewrite it as 1 over 2 cubed. In other words, 2 raised to the third power, we can also call that 2 cubed. So remember, just like always, that the exponent here tells us how many times the base will appear in multiplication. So since the base is 2 and the exponent is 3, we know that 2 is going to appear in the multiplication 3 times. All right, so we could rewrite this as 1 over 2 times 2 times 2. So why do I have 2 times 2 times 2? Well, again, there are 3 2's here, and we have 2 raised to the power of 3, so that 3 tells us that 2 has to appear in the multiplication 3 times here. Okay, So we have 1 over, now let's think about this. 2 times 2 is 4. 4 times 2 is 8. All right, so we can rewrite this now as 1/8, or 1 over 8. So 2 to the negative 3 is equal to 1 over 8. All right, or you could call that 1/8. All right, and we knew how to solve this based off of this general exponent rule right here. Okay, so definitely add these general rules to your notes here. Maybe add the examples as well. And you can pause the video, slow down, take your time, and make sure that you understand this, because we're now going to move on to the next rule. And the next rule here is similar, but it's a little bit different. All right, so this time let's say that we have a base, and it's raised to an exponent here. All right, and that exponent is positive this time. So note that when you have any number, right, raised to a positive power, you can rewrite that as 1 over that same exact base raised to a negative power. All right, and the exponent is the same, it's just that it becomes negative. Okay, let me make this look a little bit more like a 1 here. All right, so this is another general rule. So any number raised to a positive exponent, you can rewrite it as 1 over that same base raised to the same exponent, but the exponent is negative. Okay, so let me give you an example of this. So let's use a simple number here. Let's say 4, and let's say that we have 4 squared. Okay, so how could you rewrite this? Well, 4 squared, we can rewrite that as 1 over 4 raised to the negative 2. Right? So another rule to remember here. So make sure you add this to your notes if you're taking notes, because this is another important rule to remember. All right, so again, as always, if you need to, you can pause the video, take your time, and make sure you understand this, because this is important. All right, so let's move on now to the next rule. And these are all very important, but this one is especially important, and this stops a lot of people up in problem solving, right? But before we look at it, I just want to add one more thing here. So it's okay if these are the same numbers, right? So you can have you could have a base raised to the same exact, raised to an exponent that's the same number, right? And nothing's going to change here, right? So some base raised to an exponent, even if that exponent is the same number as the base, the same principle is going to always apply here. So we would rewrite this as 1 over a raised to the negative a. Okay, so just for example here, and we're going to cover this a little bit quickly. All right, we have 3, say I give you 3 raised to the 3rd power. So you could rewrite that just like you always would as 1 over 3 to the negative 3. Okay, so the rule, it doesn't matter if the base and the exponent are the same number, the same rules are going to apply here. All right, so now let's get back to the next rule that I was going to show you that's really important. So what happens if we have 2 bases, and we have 2 bases and the bases are the same, and we're doing a multiplication problem. So let's say that we have a is our base and it's raised to some number, and we're multiplying by the same base raised to another number. Okay, so this is really, really important to understand for problem solving on the GED test. Well, if the bases are the same and we've got a multiplication question like this, we can rewrite that as the base raised to b plus c. Now, it might sound like I'm speaking a foreign language here because we're just looking at the general case here and we're not looking at numbers. So let's do that. Let's look at some numbers here. Okay, so let's say that we've got 2 squared times 2 to the 3rd power. All right, so how can we rewrite this? 2 squared times 2 to the third power. So this would be a good time to pause the video, think about this general rule, and think about how you could do this multiplication based off of this general rule. So go ahead and pause the video, think about this right now, and then we'll go over how to do it. Okay, hopefully you had a chance to try this. So we want to remember that when the bases are the same and we've got a multiplication question here, that we can just keep the same base and add the exponents, right? So we can rewrite 2 squared times 2 cubed as 2 raised to 2 plus 3. Okay. Now we can simplify that even further, right, as 2 to the 5th power. Now why did I rewrite that as 2 to the 5th power? Well, the reason I rewrote that as 2 to the 5th power is because 2 plus 3 is 5. Alright, and so for the sake of time we're not going to solve this here, but hopefully you remember that 2 to the 5th power, to solve that you would need 2 to appear in the multiplication 5 times. So you would do 2 times 2 times 2 times 2 times 2. Alright, so let's look at one more example of this. Alright, so let's say that we've got 3 raised to the third power times 3 raised to the 10th power. Okay, so just focus on this right here. 3 cubed times 3 to the 10th power. Now based off of this general rule right here, how could you rewrite this? So you don't have to solve it. I'm not looking for you to solve it and give me the number. I'm just looking for you, I just want to see if you can take this example here and rewrite it based off of the rule. So you can do it right now, pause the video and try it. Okay, so hopefully you had a chance to try it. So let's go over this. So the bases are the same and we've got a multiplication. So we know that we can just add our exponents here. So we can rewrite this as 3 raised to 3 plus 10. Okay. Now what is 3 plus 10? 3 plus 10 is 13. So we can rewrite this as 3 raised to the 13th power. Make sense? Excellent. Okay, so now let's move on to another rule here. And again, as always, you can rewind, pause the video, take your time, make sure that you understand this because each one of these rules are very, very important for problem solving. So now, in this case, we just looked at a case where the two bases are the same and we're doing a multiplication, and we saw that we can add the exponents. But let's think about division this time. So let's look at the general rule, and then we're going to look at an example. All right, so now let's say that you've got some number raised to the b, and then you've got that same base raised to the c. So how can we rewrite this here? Well, the bases are the same and we're doing a division. So we can rewrite this as a raised to b minus c. Okay, so this is another one of these general rules that I want you to keep in mind here. All right, so this is also one of the most important rules that you can know for the GED test. So as always, let's look at an example here. So let's say that I've got 4 raised to the 5th power, and I want to divide that by 4 raised to the 3rd power. So again, I'm not looking for you to solve, I'm not looking for you to give me the answer here. I'm just looking for you to rewrite this based off of the general rule here. Okay, so pause the video now and I just want you to rewrite it. Okay, so let me show you how to do it. So we see that the bases are the same. So we have 4 raised to 5, 4 raised to 3. So since the bases are the same, we can rewrite this as 4 raised to 5 minus 3. Now what is 5 minus 3? Well, 5 minus 3 is 2. So we can end this as 4 squared. Alright, and I said you don't have to solve it, but let's just solve this because this is an easy one to do. 4 raised to the power of 2. That's the same as 4 times 4. Now 4 times 4 is equal to 16. Okay, so we see that 4 raised to the 5th power divided by 4 cubed, this whole thing right here, right, this is just equal to 16. Okay. Alright, so if you're not following this, make sure that you rewind the video, pause the video, think about this, ponder it, make sure that you've got this down because it can seem a little bit confusing at first, alright, but it's really not that complicated once you just practice. Make sure you can follow these examples because now the reason that I want you to make sure that you have understood everything up in the video up until this point is because we're going to look at the ultimate test here because I really want to see how well you understand exponents. So I'm going to set you up here with a tough question here, alright? Now, this is a tough question here, and I don't want you to think I'm setting you up to fail, because I would certainly never set you up to fail, purposely at least, okay? But this is a tricky question, and if you understand this question, then I would say that you have a good understanding of exponent rules. So let me write this question out, and then of course I'll tell you what I want you to do here, and I'll make sure that you understand what these numbers and letters are, because I know that my handwriting can be hard to read sometimes, so don't worry, we're going to clarify it in just a second here. Okay, so right now what I have up here on the screen is x raised to the negative 3 times y raised to the negative 2 times z raised to the first power. Okay, but we're not done yet. So this is divided. This is going to be divided by x raised to the negative 7. Okay, and then we've got y raised to the negative 5, and we've got z, all right, raised to the 0 power. So this is really the ultimate test, and I'm putting a line through the z here so that way we know that it's not a 2, because I don't want it to get confused with a 2. So this is really the ultimate test, all right, of how well you understand exponent rules here. All right, so again, we have x raised to the negative 3 times y to the negative 2 times z to the first power, all over, or in other words, divided by x raised to the negative 7 times y to the negative 5 times z to the 0. Okay, so if you get this question right, I want you to let me know down below in the comments, because if you get this right, then I would say that you have a really good understanding of exponent rules and power rules, and you should be fine for the majority of cases you could get on the GED test. All right, so I want you to pause the video now and try this question, and I just want you to simplify this as far as you can to give me your answer. All right, so go and try it right now, and then we'll go over it. Okay, time to go over this question here. Okay, so the first thing that I want us to note here are the similar bases, right? So we've got x raised to the negative 3 and x raised to the negative 7. Okay, so the first thing that we can do, all right, is we can rewrite this so that we've got positive exponents, right? So this x raised to the negative 3, okay, we can move that down into the denominator of the fraction. So the bottom portion of the fraction is called the denominator. So we can take this x to the negative 3, we can move it down to the denominator, and it's going to become x raised to the positive 3. And likewise, we can do a switcheroo with this x to the negative 7 as well. Because if we take x to the negative 7, move it up into the numerator, all right, it's going to become x raised to the 7th power. So we can rewrite this as x raised to the 7th power, and remember that x raised to the negative 7, if we move it upstairs into the numerator, it becomes positive. All right, so we've got x raised to the 7th power, and we have x raised to the 3rd power. Okay, and again, this just comes out of those general power rules. So if you thought that those examples earlier in the video were too easy or too simple for you, then make sure that you know how to apply them here, because this is a harder case. Okay, so let me just draw a line through here so we delineate the problem from my explanation here. So we now have y raised to the negative 2 over y to the negative 5, and we can do the same thing. So we can pull this downstairs, and it becomes y to the positive 2. We can pull this y to the negative 5 upstairs, and it becomes y raised to the positive 5. All right, so let's do that. So we can rewrite it as y raised to the positive 5, and y raised to the positive 2. Okay. And so for the z's here, do we really need to do anything because these are both, we've got a 0 and we've got a 1 here. So just remember the basic rule, right, that says that when the bases are the same and we've got a division, all right, we can do a subtraction here. Okay, so this z to the positive 1 over z to the 0, all right, we can just rewrite that as z raised to 1 minus 0. And 1 minus 0 is just 1. So really, okay, when we rewrite this, we're going to have z raised to the first power. And we know that any base raised to the first power is just equal to that same exact base. Okay, so let's rewrite this now. And what we can do, remember that subtraction rule because we've got the same bases here. X raised to the 7 divided by x raised to the 3. Well, we can subtract. We can do 7 minus 3, which gives us x raised to the 4th. Okay, and we can do the same thing here with the y's. We've got y raised to the 5 divided by y raised to the 2. All right, and that becomes y raised to the 3 because 5 minus 2 is 3. Okay, and z, again, z to the 1 minus 0 is just z to the first power. Any number raised to the first power is just equal to itself. All right, so our final answer here should be x raised to the 4th power times y raised to the power of 3 times z. Okay, so if you got this right, then congratulations, you did a phenomenal job. All right, if you didn't get it right, make sure that you can follow this, right? And if you're having trouble following this, then you're most likely a little bit rusty on one of those power rules that I showed you earlier in the video, because all of those power rules from earlier in the video that we've been going over here, all right, all of those I incorporated here into this example, all right, for the most part. And so basically, the only one that we didn't do was like this one. Remember this a to the b times a to the c. Okay, and so remember when it's multiplication here, we're just adding the exponents up. So we didn't look at that one here, okay, but we looked at the other rules, right? We've got x to the negative 3. We knew that we could pull that downstairs and make it x to the positive 3, all right, and so on and so forth, okay? But if you didn't understand this, make sure that you go back, watch this slowly, make sure that you understand this, guys, because if you understand this, then you're going to be in really good shape for the majority of those exponent questions on your test. Your next step is to go test yourself on GED exponents with my GED Math Practice Quiz. That'll show you where your weak areas are, not just for GED exponent rules, but also for other high-yield topics that come up often on the GED Math section. So go try that out now, and again, as always, make sure you click subscribe down below for more videos to help you pass the GED.